I will be explaining you this theorem. Linearity and monotonicity of integration for a real valued function. Okay, this is a university question. Previous year asked university question. So this is important, no, expected. So let's see the statement. This is statement. Sorry. Okay, let's follow my notes. Okay. Linearity and monotonicity of integration for a real valued function. This is the statement. Okay. Let f and g. Here you are having two functions. How many functions? Two functions. F and g. Okay. We are saying this f and g are what? Integrable over e. What is e? E means measurable sets. Okay. Measurable set. So let f and g be integrable over e. Then for any alpha and beta, you are taking two, what is that? Two elements, you can say. Okay. Alpha and beta, the function alpha f plus beta g is integrable. Okay. This is what you have to prove. First thing you are going to prove this. That is, first you have to take two functions f and g, and then f and g is integrable over e. Then you have to prove alpha f plus beta g is also integrable. This is what we have to prove. Is that clear? This alpha and beta are any elements. Okay. For any alpha and beta. Okay. So here first you have to prove this. After that you prove this. You will prove this condition. That is integral alpha f plus beta g over e is equal to alpha integral f over e plus beta integral g over e. This condition you will prove. After that, moreover, if f less than or equal to g on e, then this condition you will prove. Okay. So when you see this question in the question paper, first thing should come in your mind is two functions. What are they? F and g. This f and g are integrable over e. Then for any alpha and beta, this is integrable. First thing you have to prove in this theorem, and then you will prove this. And after that, moreover, to write this you should not feel confused. Just write this with the integral e. Okay, integration e. Write this in the left hand side, and then equal to, bring this alpha outside and write this first term, and plus bring beta outside the integral and write like that. Okay, don't memorize. Understand the difference. Understand what is there. Okay. Okay. Moreover, if f less than or equal to g means, if this function is less than or equal to this function means this inequality is there. That is what we have to prove. So let's see the proof. First, what you are going to prove? You are going to prove alpha f plus beta g is integrable. Okay. Let's see the procedure to prove that. In the statement you are having f and g are integrable. That is what you are writing. Copy it. Since f and g are integrable, by the definition we write. By the definition of integrable, you are writing this. For f you are writing this. For g you are writing this. Okay. Since they are integrable, no. So you are using the definition of integrable and writing like this. Now, what you are writing is integral modulus of alpha f plus b. You are considering this. Okay. You are considering this. Okay, integral modulus of alpha f plus beta g over e less than or equal to, here what you are doing is you are splitting this modulus to all the elements. So when you split the modulus, the inequality will become like that. Right? No, that is what the procedure. When you split the modulus, this will happen. So that is what is happening here also. So after splitting this, what you are doing is you are bringing this alpha outside. Sorry, you are multiplying this. One step is missing. You can add it. After that, what you are doing, you are bringing this mod alpha outside this integral so that you will get, plus you are bringing mod beta outside the integral so that you will get this. You are having, this is less than infinitive and this is less than infinitive. So when you add these two, that will also what? Less than infinitive. So that is what you are writing. Less than infinitive. So you got this less than infinitive now. So by the definition of integrable, you are getting this. You are getting this. Is that clear? Okay. So now let us concentrate to prove this. To prove this, before that, first you are proving this, okay? To prove that. After that, you will prove this. Okay. After proving these two, you will, from these two things, you will compare it and you will prove what is there in the statement. Is that clear? Okay. Here look at this. First, to prove integral alpha f over e is equal to alpha integral f over e, you are having two cases here, okay? The first case is alpha greater than or equal to 0, and in the second case you are having alpha less than 0. Is that clear? Okay, let's see case 1. Case 1, alpha greater than or equal to 0. So we are having this from the definition, alpha is equal to, you can write, that is, you are having f equal to f plus minus f minus. Here in the place of f, you are having alpha f. So it becomes the definition. This format you are writing in that format. Now you are having, this is also you are having result. I told you in another video. Look at this. F plus of x equal to this. F minus of x equal to this. Okay. These are the definitions. So from that, using that, you are writing alpha f plus of x is equal to maximum alpha f of x comma 0. Now we are bringing alpha outside so that you will get this. Now maximum f of x comma 0 can be written like this, f plus of x, so that you are getting this. Similarly, you can find for alpha f minus of x. So when you find that, when you do like this, so that you will get this. Okay. So after finding these two, what you are doing is, consider integral alpha f over e is equal to, that is, in the place of the same thing, for this you are applying integration. Okay. Now after that, you will apply the values, these values there. That is what you are going to do. So after applying integration, the value of this here just before you have found, no? So just apply it and the value of this you are applying. Now you are bringing this alpha outside this integral so that you will get this. Here also you are doing the same. Now after that, you are bringing alpha common, taking alpha common because you are having alpha in these two terms now. So you are taking common so that you will get this. Now here, what you can do is equal to alpha. I hope you can get that. Here is also integration. Here is also integral over e. No? So you are taking common and write f plus minus f minus. Okay. You are having a value. F plus minus f minus is what? F. So that is what you are writing. Alpha integral over e f you will get. Okay. Now in case 2, alpha less than 0 as I told you. Similarly, here you are finding alpha f plus of x and alpha f minus of x. The same thing you are doing. Integral alpha f over e is equal to, and in the place of this you are substituting the values you have found here. Okay. Now the same thing you have done like you do in the case 1. So you will get this. Hence you proved it. This is what you wrote, right? First to prove that line. So you proved it. After that we are going to prove this. Next to prove this. Okay. Okay. We are going to prove this. Okay. To prove this, what you are doing is you are writing this. How you are writing this? You know, right? F equal to f plus minus f minus. So here in the place of f, you are putting f plus g. That is what the only difference. So you are writing this. We have. Now, you can write f like this, no? Write that. You can write g like this, no? You are writing. Now, f plus g whole plus and minus f plus g the whole minus. You are writing as it is. Just copied. Now you are applying integral over e throughout, so that you will get this. After that, here you can write, look at this. This can be written like this, f plus g. F plus g can be written like this. No, f plus g whole plus minus f plus g the whole minus. So that process you have done here, so that you will get this. So from this what you can do here, from these two you can take integral over e common, so that you will get f plus minus f minus, right? So that you can get f. So that simple process is happening and you will get this. Who is playing the hero role here? This is playing a main role here, okay? Compare that steps with this and do it. So finally you proved this also. So that what you can say, integral over e alpha f plus beta g is equal to integral alpha f over e plus integral beta g over e. You proved it. Okay. From that too, you proved it. Now from this you are taking alpha common, alpha outside the integral, so that you will get. This is what they are asking us to prove in the statement, no? So you proved it. Now you have to prove it. If f less than or equal to g means, then you have to prove this. To prove this, what you are doing is, let h equal to, you are taking like this, h equal to g minus f. Now consider you are taking integration to these two. Integral g over e minus integral f over e is equal to integral g minus f. You are considering this, okay? This can be written like this. And now you know that g minus f value just above you have took like this, so you are putting h. This value will be greater than or equal to 0, because you are having f less than or equal to g, no? So that is why this value will be greater than or equal to 0. Okay, because this is greater minus smaller value. So when you subtract greater value minus smaller value, what do you get? You get a positive value, no? So that is why greater than or equal to 0. So left hand side greater than or equal to 0. So from this you can write like this. So you proved this proposition. Proposition or theorem? It's a theorem, no? So you proved it, hence the proof.